Okay, finally we hit a week in geometry where we get to do geometry. Yay! The algebra review that we had was to make sure you were solid on that, because now every bit of geometry that you see in this class will go back to that algebra, but I won't have to focus so much on how to solve because you will have had a little practice with that. So now we get into geometry, which a lot of the year, guys, is going to be circles and triangles and angles. And so we're going to start with triangles because I feel like that's probably something that you're more familiar with. And the first one is just, what do you already know about triangles? So take a minute and hit pause and please write down what you know about triangles. It could be basic, it could be difficult, but just think of everything you can possibly think of. And when you're finished, come back and let's see if we match. Okay, so take a minute and pause. Okay, so not sure how much you wrote down, but some things that I feel like you would already remember is the basic, there are three sides to a triangle, and the angles, you may know that the angles add up to 180 degrees, okay? Angles add up to 180 degrees. That's usually what people remember. Some people remember that a right triangle is a triangle that has a right angle, which means a 90-degree angle. So a lot of people remember that. Some people remember things like isosceles or equilateral, obtuse, acute. Okay, if you remembered all that, that is awesome. If you don't, this video will go over it, so don't worry about that. So not sure what you put here, but let's see if we can cover it and maybe teach you some new things in this video. Okay, what will be the focus in high school geometry? Okay, classifying triangles is a big deal, and classifying just means to understand what type of triangle is it, like to be as specific as possible to figure out what kind. You're going to do a lot of finding the missing sides, and that's what we did last week, and we're going to do finding the missing angles as well, okay? But you're also going to be having to find missing parts using algebra. So that would be a couple of things that you could write down there for the main focus in high school geometry. Okay, so finding a missing angle. Well, the thing is, sometimes it's not really that difficult at all. Like sometimes you'll have a picture and maybe that'll be labeled with a 70 and maybe that's a 65, and then you're supposed to find the other angle. So you could have a question mark there, you could have an X. I mean, I don't know what there's going to be in the corner, but it'll be missing, okay? And so sometimes it's pretty basic where if you know that, okay, all three have to add up to 180, then you can make a little equation out of it, okay? So this one, this angle in the corner, plus this other angle up top, plus the angle we don't know has to equal 180. And then you can just solve. And so some of you, another way to think about that is you just need to subtract both of those, and then that'll leave you with whatever's left. So if I subtract 70 and 65 from this side, I need to subtract 70 and 65 from this side. So what you would do is with a calculator, 180 minus 70, and that would be 110, and then 110 minus the 65, and that would give you 45. That would give you 45 for your remaining angle. Did I do that right? Oh, I think I did. So then you would know that 45 is your missing angle right there. So that is one example. A trickier missing angle might be something where they do like, okay, smart guy, maybe it looks like this. And so that's trickier for some people because they forget what this means. And but just keep in mind that that does just mean 90 degrees. And so you could do the same thing that we did here. This 90 degrees plus this 35 plus this angle at the top is equal to 180. And you could do it that way. And so we would take the 90 and the 35 and we would subtract them from both sides. And so whatever this is, which I think is a 55, that would be your answer for the top angle. Now it says again, but worse this time. Okay, so how could it possibly get worse? Well, what if both of these angles are labeled with X's or unknowns? And maybe even all three, I don't know. Maybe this says 40, but then this one is like 3x, and this one's like x plus 10, something like that. And then all of them are labeled all funky, and you're starting to wig out a little bit. Okay, it's the same thing as what we did here. If you add up all three angles, they have to add up to 180. So we're just going to start listing it out. So 40, this angle, plus this angle, 3x, plus this angle, x plus 10, all of them together have to be 180. And this is why we worked so hard the last 2 to 3 weeks on your algebra, especially week 1 we worked on algebra, because you have to be able to solve this. So the way I would do it is I'd go ahead and put the 40 and the 10 together. So 40 plus 10 is 50. And then I would put these two together. So what's a 3x plus an extra x? That's a 4x. And then I'd recopy this side. Now I just solve it like normal. Subtract 50, subtract 50. 4x equals 130. And then how do we get that x by itself? Well, now we would divide off the 4, divide off the 4. So 130 divided by 4 might be, does that go in there evenly? Let's see, 4 goes in there. No, it doesn't go evenly. Gag. Okay, let me divide both by 2. Let me reduce this fraction. So I'm going to divide that by 2. Let me divide the top by 2, and that would be a 65. Okay, so 65 over 2 is your x. And sometimes this takes an extra added step, everybody, because the thing is, they don't want to know what x is. They want to know, like, what is that angle and what is that angle. So you can't just stop at x equals 65 over 2, which I know that that's like 32 and a half or whatever, but that doesn't matter. You're going to have to take that and plug it in so that you know that that bottom corner angle is really 3 times 65 over 2, which is whatever that is, 195 over 2, okay? And if you did that with a calculator or if you turned it into a decimal, it looks like it's going to be a 90-something. Hold on, 97.5, I think. And then you'd have to plug it into this one as well. So we would take this, which is a 32.5, and add it to 10, and that would be 42.5. So see, you'd have like all of these funky angles, but if you add this and this and this together, we should get 180. And if you test me, I think you'll see that it actually does work. All right, cool. So now what? That's about as hard as it gets in high school geometry. It only gets trickier if they don't give you like everything labeled, but instead they describe a triangle to you. And this was that classifying triangles things that I'm talking about. So we first need to talk a little bit about labeling and the different kinds of triangles, okay? So here we go. So classifying triangles. So there's a bunch of words that might be used. Isosceles is one of them, equilateral, right. These are all different types of triangles. Isosceles, equilateral, right. Scalene is also a type of triangle. Obtuse and acute. Okay, so here's the thing, and I should have color-coded these. You will be able to, these three, you'll be able to choose one of these three, isosceles, equilateral, and scalene, and that's going to talk about the sides. So the ones that are underlined talk about the sides of a triangle, And then the ones that are in blue, these three right here, are a way to classify the angles of a triangle, okay? So I'm going to color code. You can do whatever you want in your notes, but kind of make a note that acute, okay, right, obtuse, acute. These are going to help with angles, and these are going to help with sides. So we're going to talk about what they mean, but first let's talk about actually labeling congruencies on a triangle, okay? Now here I put equilateral triangle because most people remember that equilateral means that all the sides are the same. So even if you're not good at drawing a triangle with all the sides the same, you might just draw a triangle and do this. Anytime you draw one line through all three of these, it means that they're the same. So if I draw one line, and one line here, that means they all match, and that's your giveaway that it is equilateral. So all the sides are the same, okay? Now, one other thing you might want to know is on an equilateral triangle, all angles are the same also. All angles are the same, and in fact, they're 60 degrees. So if you want to label an angle as being the same, a lot of times you'll see this. And so if they're all drawn the same with just one little curvy thing on them, then that means all of these are the same. So you'll see that a lot of times, okay? Now, what about labeling the congruencies on an isosceles triangle? Okay, on an isosceles triangle, that means that two sides match. Okay, so two sides are congruent. So it might look like this. Notice I'm drawing what looks to be the same pictures over here, but the labeling would be different because maybe these two match, but that one's a little different. So if it's a little different, you just won't see anything labeled. Now the angles on an isosceles triangle, two angles will also match. So you may or may not know this, but if two sides match, then what happens is that the opposite angles will also match. So if this is the side, you go across the triangle, and this angle will be the same as this angle. Now over here, they were all 60. On an isosceles triangle, you actually do not know what they are. You would have to figure that out. But you just know that whatever this one is, it would match that. But I can't give you like, oh, it's going to be 50 degrees, because I don't know what it's going to be. It depends on the picture. It depends on how long everything is. So anyways, that's how you would label the congruencies. Now, scalene is not up here. So equilateral, isosceles, scalene, I did not give a box for, because guess what? On a scalene, nothing matches. Nothing matches. Nothing. No angles, no sides, so no picture. That's why I did not include it. It would just be a random, okay, nothing matches and nothing is labeled, okay? So what about obtuse, acute, and right? Well, I'm going to start with right because you actually did that last week. Now, if it is a right triangle, you will see the little box drawn in the corner over here. And you even learned last week how to verify a right triangle because you have to make sure that a squared plus b squared equals c squared. So I don't need to necessarily mark any of these as congruent. You would just check to see, does a squared plus b squared equal c squared? And that would be how you could check to make sure that it's right. But if you get a picture and somebody draws that for you, it is definitely a right triangle, okay? Now, what about obtuse and acute? Well, most people learn acute when they're in elementary school, and an acute triangle just means that all of the angles are less than 90. All angles less than 90. So they are smaller than that. They're smaller than 90 degrees. And the way my teacher used to talk to us about it is, oh, look, it's a cute little angle. A cute little angle, a cute little angle. And so if you think cute little, then maybe that'll help you remember it, but they're all less than 90, okay? Now, obtuse, this is going to sound mean, but honestly, my whole life, I see that O and I think obtuse and I think obese. I don't know, I just always have. So, obtuse, obese, big. So, the obtuse angles are bigger than 90. Now, it's not all angles bigger than 90 because that would be like impossible for me to draw, but it's going to have one angle that's larger than, not one angles, one angle larger than 90 or greater than 90. And so to draw these, just make sure that you draw one angle that's bigger. See, like that's definitely bigger than 90, and then connect the dots. So it'll always look like this. It'll have one obtuse angle, or one big angle, and then two little ones, okay? And that's how they are. And I'm not labeling anything as congruent, so notice no tick marks on the side, no angles being labeled, because it's not necessarily going to work out that way. Sometimes it does, but it doesn't have to, okay? So that would be acute, and that would be, I should have labeled those, sorry. And I left out the T, it's not obtuse. That's weird. Obtuse. Keep in mind I am a math teacher, and that doesn't excuse poor spelling, but I like to remind people that, yeah, sometimes I overlook things, so I apologize. That would be obtuse, not obtuse. All right, cool. So now what? Now let's practice classifying triangles. Now that we've taken the notes over it, we are going to practice. So is the following triangle equilateral or isosceles? Okay, so we're going to practice. Maybe you see something like this. I'm going to give you time to sketch this and then time to think about it, and you can tell me what you think. So is it equilateral or isosceles, or maybe neither? Well, if this is the picture that's given to you, if they tell you for sure that there are two equal sides, then you can immediately say, yes, it is isosceles. And you know what else you can do? Even if they don't draw it, okay, even if they don't draw it, you can add to the picture. You can add congruency marks to the picture. And in fact, you need to learn how to do this, because in high school geometry, they never label everything for you. They give you a hint, and then you have to take their hint and run with it. So if I know that these two are equal, remember the opposite angles, so go across the triangle. These are also equal, so I'm going to label those. So I know I added them, but it's okay to add them if they tell you that those are there, because that's just the rule or the definition, okay? Is the following triangle equilateral or isosceles? So let's pretend that somebody gives you this. I'm changing that, sorry. Changing this, let's change that to a 5, and a 5. Okay, so here's a picture. They haven't labeled with tick marks, but they have told me that that's 5, and that's 5. Well, all three of these are equal, so yes, it is an equilateral triangle. Now, just like this picture over here, now I can add to this picture with my own stuff. So if I know that that's equilateral, I also know that all the angles are the same. And do you remember what all the angles are? Well, I think we wrote it on the other thing. They are all 60. So feel free to fill in the extras if you're given a clue about something else. Okay? All right, cool. Now, if the angles of a triangle are 10x, okay, we're talking about angles of a triangle. Now, I need a picture, everybody. I need a picture. So just draw a random triangle, and let's start filling in the picture. If the angles are 10x, 20 minus 15, or sorry, that's 20x minus 15, and 9x, decide if the triangle is acute, obtuse, or right. Okay, so it's given us these three things, and we've got to figure out acute, obtuse, or right, which means we need to know what are the angles. So we really do. The goal is to find all the angles first, then make the decision on what kind of triangle it is. Now, how do I find all the angles? Well, we do it like we did earlier. The total amount in a triangle is 180 degrees. So I'm going to take all three of these and add them together. So 10x plus the next one plus the next one. They all have to equal 180, okay? And then I'm going to solve this out. So 10x plus 20x is 30x plus another 9x. So 39x, and then I'm going to recopy minus 15 equals 180. I'm just solving. I'm just combining like terms. Now I'm going to add 15 to both sides because I'm just trying to solve this bad boy out. And that would be what, 195? Is that right? And now I'm going to divide by whatever that is. Divide by 39. Now, does 39 go into 195? I sure do hope so. Gosh, I may have to do this math out to the side. Let's see. Let me get myself a little bit more room. Hold on. Hold on, we're getting there. Okay, so I'm just going to kind of go out to the side, everybody, and try to figure this out. If it goes in evenly or not, maybe 5 times. Let me try 5. 39 times 5 is 45, and then that would be 15. Oh my gosh, that works. Okay, so this is a 5, so x equals 5. Yay! Okay, they don't care about us knowing that x equals 5. We still haven't answered the question, so we still need the angles. So take the x equals 5, plug it into all 3 of these, and figure out what your angles are. So I'm just going to plug into the top first. The top angle is 9 times x, or 9 times 5, so this one's 45. This one is 10 times x, 10 times 5 is 50. And this one over here is 20 times 5 minus 15. So 20 times 5 is 100. 100 minus 15 is 85. Okay, so now I look at all of my angles, and my job is to see which of these 3 that it is. So I have, this is less than 90, less than 90, less than 90, so this must be an acute triangle. Now, don't try to be like, oh, well, I drew it that way in the beginning, so I already knew it was acute. Oh, no, no, no. We just totally made up what the picture would look like. We don't know if our picture is accurate or not until we find these 3. Then, then we can say, okay, our picture looks right. But you've got to go through all this work. Unfortunately, there is no shortcut to figuring this mess out. You have to do what I just did. Now, this bottom box, guys, I'm not going to add anything here. This is for you. If this is the first lesson where this is some new stuff, what might be hard for you to keep straight, make notes here. This is yours. Just anything that struck you as weird or different or, oh, I don't want to forget this, please write it in the box. This is for you. And then use these notes to do your assignment. I've noticed that some people are just, they're not really looking at their notes. They're just trying the problems, and then if they get stuck, they say, oh, well. But remember to look back at this, and it could help you through your homework. All right. Good luck on the problems. Peace.